Hello everybody and welcome to today's lesson on angles around transversals of parallel lines. This is part of a Unit 3 on parallel lines, and since I heard there was some disappointment that I didn't give you my signature greeting in the last class, let me say it again. Hello everybody and welcome to today's class. Our objective for today will be to be able to identify angle pair relationships and use them to solve problems involving parallel lines cut by a transversal. In order to do that, I'm first going to show you a pretty neat website that you can also use in your own time and look at and practice. It's called www.mathopenref.com. Let's go there right now. And here we are looking at a picture of two parallel lines, which is indicated by the two arrows that these two parallel lines have. It's the same symbol, that means they're parallel. And there's a transversal going through those two lines. And as you can see, that creates a whole bunch of angles. We see 8 angles in total. 4 of them are acute angles with 70 degrees of a measurement, and 4 of them are obtuse angles with a measurement of 110 degrees. And as you can very clearly see, all the acute angles have the same measurement, and so do all the obtuse angles. Well, let's move this around a little bit and see what happens. If I move my transversal around, you see that obviously the measurements of those angles change. As I move it more to the left, you see that the acute angles get smaller, the obtuse get larger, and as I keep going to the right, the acute angles get larger and the obtuse angles get smaller. But as you can clearly see, the angles, the 4 acute angles, always change the same way. Their measurements stay the same. And the same is true for obtuse angles. In other words, we have 8 angles here, but we have only 2 different measurements. We have 2 groups of 4 angles that all have the same measurements. And I can even go further to that side. Then, of course, what used to be the obtuse angles are now going to become the acute ones, and vice versa. But the same situation persists, and we have only 2 measurements to worry about. And to make matters even neater, you know that each one of these acute angles together with an obtuse angle to one of its sides together make a straight angle, since there's a straight line, and those angles add up to 180 degrees. They are supplementary, and even because they're next to each other, they are also linear pairs. This is just a little bit of vocabulary review from last class. So then let's get back to our notes and get started. The corresponding angles postulate states that if two parallel lines, now this is way too big, isn't it? Much better like that, right? If 2 parallel lines are cut by a transversal, and really the point is that these lines are parallel. Remember, in the last class we talked about all sorts of things happening to angles when 2 lines get crossed by a transversal. Now these 2 lines we're talking about are parallel now, because now that they are parallel, we can not only state their relationships in terms of using the different vocabulary, but also the measurements. Okay, let's get going. Third attempt. If 2 parallel lines are cut by a transversal, then the pairs of corresponding angles, you remember this vocabulary, are congruent. Pairs of corresponding angles are congruent. And let's look at our example. Given the lines J and M are parallel, that's that little symbol here with the 2 vertical lines, that means J and M are parallel, And how do we indicate that on a drawing like this? We use an arrow symbol on both of those lines. Now the arrow that you choose can be any type of arrow. It can be an open arrow like this, it can be a closed arrow like this, or it can even be filled out. The point is that it has to be the same symbol for both lines. Then we know and we realize that these lines are parallel. So those two lines, J and M, are parallel, and I have the measurement of angle 3, that is 140 degrees. Let's see where angle 3 is. Angle 3 is right here, and we're saying that angle 3 has a measurement of 140 degrees. Then angle 7 is down here, and angle 7 is the corresponding angle. Remember, that means that it's in the same position at the other line, and that corresponding angle has the exact same measurement of 140 degrees. Let me write that down here as well. Those two angles have a measurement of 140 degrees, and that's what the corresponding angles postulate tells us. The alternate interior and the alternate exterior angles theorem state that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent, and the pairs of alternate exterior angles are also congruent. By the way, what's the difference between a theorem and a postulate? Postulates are statements that are accepted without proof. See, the corresponding angles postulated from the previous page is pretty straightforward, right? Theorems are statements that must be proven first before they can be accepted. Excuse me. So, let's look at an example. And we remember alternate exterior angles means those are two angles that are on opposite sides of the transversal, and they are on the outside of the parallel lines. Alternate interior angles are the ones that are on opposite sides of the transversal, and they are between the two parallel lines. Now let's look at our angles here in the example. Given lines J and M are parallel, and let's not forget to make our arrows to indicate that. I'm just going to use simple arrows this time. Remember, they have to be the same, and they should also be different from previous examples, since these lines are most likely not parallel to the other lines. Anyway, angle 4 is right here. That's an interior angle, has a measurement of 30 degrees. And what is the angle? That's the alternate interior angle. It's on the opposite side of the transversal and in between the two lines, angle 5. And then if angle 4 has a measurement of 30 degrees, then angle 5 also has to have a measurement of 30 degrees. That's all the alternate interior, in this case, angles theorem says. Let's go to our next example. And this one I'm going to let you try and figure out yourselves. I'm going to stop the video, or rather you should do that right now, and try it yourself and then compare your work with my answer. Hopefully you came up with the same answer, realizing that angle 2 is on the outside, and that means it's an exterior angle. It has a measurement of 120 degrees. The alternate exterior angle, in other words, on the other side of the transversal, also outside of the parallel lines, is angle 7 and has also a measurement of 120 degrees. Well done, guys. Let's move on. So our theorems and postulates we just talked about also have converses. And we remember from our first unit that the converse is when we take a conditional statement and flip it around, right? So see, that all comes back. So the converse of our theorems and postulates, the corresponding, the alternate interior and alternate exterior angles converse, goes like this. If two lines are cut by a transversal, so the corresponding or the alternate interior or the alternate exterior angles are congruent, then the lines are parallel. See, you realize our statements went in nice if-then form, and we just flip them around for the converse to get the converse, right? Duh. So now we're saying if for some reason we realize that those angles we're mentioning, the corresponding, the alternate interior or the alternate exterior angles are congruent, and we figured that out without knowing that the lines were parallel, well then we can say that the lines that have been crossed by the transversal are indeed parallel. Let's look at an example. If the measurement of angle 1 is congruent to the measurement of angle 5, then let's first try and figure out where those angles are, and then we do the rest. Angle 1 is out here, and angle 5 is in here, so they are in the same position on the two different lines. These are corresponding angles. And now we're being told these corresponding angles are congruent. They have the same measurement. Well, then our lines J and M are indeed parallel. And since we have a whole bunch of converses that we're talking about here, specifically right now we have used the corresponding angles converse. Remember, our neat little symbol for angles goes like this, and this was the corresponding angles converse. The alternate interior and alternate exterior angles converses, I guess, work just like that. So if you're up to it, just go ahead. Why don't you make up your own example? We're going to move on, and we're going to talk about the consecutive interior angles theorem. Consecutive interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. Aha, so now we're no longer talking about congruent. These angles are not congruent. These angles are supplementary. Wait a minute, Mr. Fieser. What does supplementary mean again? Yes, you're right. They add up to 180 degrees. They add up to 180 degrees together. That always means we are forming a straight angle. In other words, their outside edges make a line. Okay, let's look at our example. Now we're back to the original statement. We know that the lines are parallel. Given that J and M are parallel, and now we're also given the measurement of one of the angles, and we have the measurement of angle 6 right here, which is 140 degrees. Well, then let's see. We got a consecutive interior angle, and the consecutive interior angle is here. Now you will notice that I'm making two arcs here for angle 4, because remember, those arcs also indicate if two angles are congruent with the previous ones. Those angles always were congruent, so if we mark two angles, we use one arc for each of them, or 2 or 3 for each of them. The same number, the same symbols indicate congruency. Now these two aren't congruent. These two are supplementary. Angle 4 gets 2 arcs from me, and it also has a different measurement. And maybe to make this even clearer, I change the color. The measurement of angle 4 now is a measurement that we get when we take 180 degrees and we subtract 140 degrees from it. Didn't need to necessarily write that down, but just in case, right? Which gives us the answer 40 degrees. Angle 4 has a measurement of 40 degrees. All right, well done. And the consecutive interior angle theorem also has a converse, which is called the consecutive interior angles converse. We got a lot of does in today's class, don't we? If two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. We're switching around the two parts of our conditional statement, and we're saying now we know that they're supplementary. For some reason, we're given that information. And if that's the case, then the lines we're talking about have to be parallel. So let's look at angle 3 and angle 5. Let's locate them first. We got angle 3 right here. We don't really know what the measurement of angle 3 is. We know that angle 3 is an obtuse angle. But then we also got angle 5, which is the consecutive interior angle. Comes right next to it. And they're both on the inside. Together, we are being told that they measure 180 degrees. We don't know which one each of them measures. We know how much they measure. Together, 180 degrees. And then that tells us that the lines J and M are parallel. Alright, so much for now. Now go ahead and watch the second part of this tutorial.